Good morning, children. This is the second part of your chapter, Motion. In this video, we are going to do the types of motion. You might have noticed that different objects move in different ways. Some objects, they move in a curved path. Some move along a straight line. Some move to and fro. Some spin, isn't it? So due to the different ways of movement, motion was categorized into different types. Now what are these types of motions? The first one we are going to study about is the translatory motion. In this type of motion, every part of the object moves through the same distance in the same time interval. Okay, every part of the object moves through the same distance in the same time interval. That means the whole object moves through the same distance. Okay, there are two types of translatory motion. One is rectilinear motion, the other one is the curvilinear motion. Now what is rectilinear motion? When an object moves along a straight line, then it is said to have rectilinear motion. Okay, repeating again, when an object moves along a straight line, then it is said to be in rectilinear motion. For example, when a fruit falls from a tree, does it spin around and fall? No, it falls directly onto the ground, isn't it? Straight onto the ground. So this is an example of rectilinear motion. When a car moves on a straight road, then that is also rectilinear motion. Suppose this is a straight road. Okay, and a car is moving on it. So till it is moving on this straight line, it is in rectilinear motion. Then again suddenly there is a turn over here. So the car turns. Now the car is taking a curve. So it has come to curvilinear motion. So an object, when it moves on a curved path, is said to have a curvilinear motion. Okay. You might have seen cyclists racing on curved tracks, isn't it? They are in curvilinear motion. When the earth, simple example, when the earth moves around the sun in its orbit, this is the sun, okay, and this is the orbit. The earth moves around the sun in its orbit, then it is moving in a curvilinear motion, okay. You throw a ball. When you throw a ball, does it move straight? No, it makes an angle and goes, isn't it? So this ball, when thrown, it takes a curvilinear path. It is in curvilinear motion. There are other examples also you will find out, and in a class I am going to ask you different examples, those which are not in the book. Okay. Then we have circular motion. This circular motion is a special case of curvilinear motion. How? When the object moves around a fixed point, this is a point and this is the object that is moving in this fixed path. The point is at the center of this circle. Okay. So the object is moving around this fixed point on the circular closed path is known as circular motion. This is special case. When the curve becomes a circle, then it becomes circular motion. Okay. For example, giant wheel. You must have seen giant wheel in melas and all. It has a fixed point and it rotates around that point. Then merry-go-round. Merry-go-round in parks you all must have seen. There children sit on it and they go round a fixed point. There is a fixed point and the merry-go-round moves around it. Okay. Now next is rotatory motion. Rotatory motion is that motion in which the object rotates or spins about an axis. This axis is known as the axis of rotation. Spinning of earth on its axis. This is the axis and the earth spins on it. The earth keeps rotating, isn't it? So the earth spinning on its axis is rotatory motion. Then the wheel of the car. The wheel of the car has an axle. It has an axle, isn't it? These are the wheels. It is joint like this. So this wheel also are in rotatory motion because they spin about an axis. Then spinning top. Spinning top you all must have seen. How is it? This is a top. Okay, the spinning top also spins about an axis, so it is in rotatory motion. In this, you should note that all the parts of the object do not move through the same distance in the same time interval. Here, this portion and this the top portion of the spinning top, this portion moves a greater distance than the pointer over here. Okay, so in rotatory motion, all parts of objects, they do not move through the same distance in the same time interval. Then is oscillatory motion. In oscillatory motion, the object as a whole moves to and fro. Suppose this, it moves to and fro movement, means this is the mean position. Okay, position where the object is at rest. Okay, what is mean position? Mean position is the position where the object is at rest. Now you gently, if you push it, it is going to go up like this, and its same distance it is going to come forward. Whatever distance it is going to cover backward, the same distance it is going to cover forward. So this is oscillatory motion. You all must have seen swings, right? Then swing is an example of oscillatory motion. Then the swinging pendulum of a wall clock. This also you all must have seen. That is also to and fro motion. So that is these are examples of oscillatory motion. Now vibratory motion. Suppose this is swinging, okay, and the rate of oscillation increases and goes on increasing rapidly. Okay, the rate of oscillation, if it increases rapidly, then it turns to vibratory motion. So this vibratory motion is a special case of oscillatory motion. Okay, in this the whole body does not move. In oscillatory motion, what was happening? The whole body was moving. But in this, the whole body does not move to and fro as a single unit, but some of its parts oscillate about their mean position. That, for example, guitar. You have strings in the guitar, isn't it? When you pull the string, it vibrates in its own position. It is there in its position, but it is moving. A slight movement is there, but the whole string does not move. Does it move? The whole body does not move. Only the strings of the guitar moves. Then the motion of the prongs of a tuning fork. How is a tuning fork? A tuning fork is like this. Okay, when a tuning fork is hit, it vibrates about its position. Understood? The other types of motion we'll be doing in the next video.